Hey everybody, welcome back to the Modular Community Livestream. I say welcome back because this is actually our second episode. If you did miss our previous episode, please feel free to go check it out on YouTube. We are Chris Lattner. We answered many questions about Mojo, the language and features and all of that. This episode, however, is focused on something special. So last episode was before the launch of Mojo SDK. Mojo SDK is finally available for local download. Yay! So some more excitement here in the room. We'll work on that.
Yay.
So yay! So Mojo SDK is finally available for local download, and this episode is all about Mojo SDK. We'll be talking about its features, how to get started. I know many of you have already tried it. We'll walk through some examples, some features, the VS Code extension, how to use it, and all of that. And of course, this is a Q&A live stream, which means we are here to answer your questions. So please feel free to add your questions into the live stream, whether you're joining in from YouTube or LinkedIn. We'll try to get to as many as we can during the live stream. If we do miss your question, we always have a Discord server, Discord community. Feel free to join that. We'll continue to answer your questions there as well. So let's wait a couple minutes for people to join in. If you feel comfortable, say hello and where you're joining from. We'll wait for a couple more minutes and we'll do a quick round of introductions and get started. Awesome. We see questions coming in. That's exciting to see. We do want to focus large parts of this live stream for to answering your questions. Okay. So here's the agenda. Here's what we'll do for today's live stream. First, we'll do a quick round of introductions, and then we'll talk about what is the Mojo SDK and some of the features and why we built it, what it looks like, and all that. After that, I will dive into a quick demo. Many of you have already used it, and many of you haven't. So we'll quickly walk through the process of installation, getting started, some of the features, and then we'll also dive deep into the Visual Studio extension because we know it's a popular IDE for development, and we have an awesome extension that you can use with the Mojo SDK. And rest of the live stream is focused on Q&A. We'll also try to answer your questions during the live stream as well. Welcome. We have folks from Canada, UK, Sri Lanka, Pakistan. That's awesome. I am here in California, Bay Area. I know folks on the screen are in different parts of the world too. So let's start with the introductions. So I'll go first because I've been speaking a lot. I'm Shashank. I'm a developer advocate at Modular. And who wants to go next?
Yeah, I'm Jack. I'm also a developer advocate, so you might have seen me on Discord and GitHub. Nice to meet everyone.
Hey, I can go next.
I'll
I can go next.
Promote.
Hey guys, good to see you guys again and be here on the live stream. So I'm part of our product management team here at Modular. So I'm excited to talk about and discuss Mojo with you guys today.
Awesome.
I'm River. It's really nice to be here. I'm an engineer at Modular. I work on a lot of the SDK components themselves, so the extension, debugger, the tooling, all of that stuff.
Awesome. So welcome again. Thank you for taking time to be on the live stream. We hope to make it as entertaining and engaging for you. So let's start off with what did we launch? Pramod, I'm going to share the blog post that you wrote on Mojo. It's finally here, and we spoke about the SDK. So do you want to give a quick brief on what did we launch?
Yeah, absolutely. So yeah, we released the first version of the Mojo SDK last Thursday. Here's the blog post that Shashank is showing up on the screen. So if you scroll down a little bit, Shashank, we put a diagram in here that just showcases various components of the SDK. I mean, we're super excited about the launch. We have already seen significant number of downloads of the SDK from the community, and we have a extremely active and passionate community on Discord who've already started creating really cool projects. So I really think that you guys should go and check out our Discord server for all the cool things that the community has been building. So here's a view of what the SDK is. Currently we're starting off with supporting CPUs. We have support for Ubuntu as the Linux distribution, but we are quickly expanding to other platforms as well. And River is going to speak a little bit about that. And then on the developer tool side, the Mojo SDK includes, most of the things that you guys expect to use in a software development environment. So we have the Mojo driver that supports, the REPL environment. So you can do interactive, coding in Mojo. We also support building of executables. And then you can also run Mojo programs, have compilation and the runtime included as well. So we also ship a number of tools in the SDK. So you can do code formatting. We have a Jupyter kernel. So if you're running, Mojo notebooks, then you can fire up your Jupyter within Visual Studio Code or a Jupyter server and run your Mojo notebooks that way. We also have a really cool extension that Rivers worked on, and can talk about that a little bit in the live stream today. It's posted on the marketplace extensions that you can start using right away. I know I drew debugger in here, so we're actively working on the debugger, so you can have a full debugging workflow as well. That's going to be coming very soon in the next few releases. And then, of course, it supports Mojo as the programming language, and we also support interop with Python, so you can use all your Python libraries within Mojo programs. So it's very exciting. I'm really excited to see where we take the Mojo SDK roadmap and build out support for various platforms, various operating system distributions, add more tools. So if you have any feedback or feature requests, please post them on GitHub. We're actively looking at it, and we can start working together on building out the roadmap.
That's awesome. Thanks, Pramod. I mean, personally, I'm excited about some features like the Jupyter support and the REPL, because some people like to do the interactive way of development and some people like to do the IDE way of development. It's nice that we have options here. And you mentioned issues. Is this the right place to do the issues, Pramod? The
Yes,
modular GitHub Mojo?
Yes, if you go to the issues, then we have issues. We also have the discussions forum, so you can go to discussions and you can also file ideas and upvote ideas as well. So you can use either one. So if you go to issues, we have a template to do feature requests. So you can also file discussions and ideas as well and upvote them.
Yeah, it's making me log in, but I'll it's public, right? It's a public repo.
It's a public GitHub repository. Yes. Yeah.
Awesome. All right. Where were we? Okay, so that's what we launched, and rest of the live stream will actually show a demo of how things work, all the different features Pramod mentioned, and it's a good segue to do that right now. And quick sort of check here. Let us know if you can hear us okay. Sound we sound okay, and everything's clear on the live stream, on the comments, and if I don't hear any complaint, I'll assume everything is looking and sounding good. Okay, let's now pivot to what it is that you see when you try to get started with it. So we also launched a new website called developer.modular.com, which is where you will get access to the Mojo SDK. If you haven't signed up, I encourage you to go sign up. Once you've signed up, you will be able to sign in to the developer console with your email address or using your Google sign-in, whichever way you signed up. And you'll be greeted with a page with instructions on how to download and get started. The drop down here shows you the different platforms you can get started with. At launch, we have support for Linux-based systems. If you click on Mac, you do find instructions, but you see here that it says native support is coming. Native support is the Apple Silicon support is coming soon. But the instructions here do show you how to do a remote setup with GitHub code spaces. So you can actually get a Linux machine remote, and we'll walk you through an example that does that today. And of course, Mac, Intel versions of Mac, if you are still holding on to one of those, work, because the Intel based, and you can run it in a Docker container with a Linux container. And Windows is also supported using WSL, Windows Subsystem for Linux. So for this demo, I'll quickly walk through Linux. So the install instructions are pretty straightforward. You just copy paste this into a terminal. So what I'm going to do now is I have a terminal open. This is an Amazon EC2 instance. It's Linux, Ubuntu Linux on an EC2 instance. So all you have to do is like copy paste these commands, and it'll quickly install not Mojo, but what it installs is the Modular CLI tool. Okay. So as soon as this is done, you will see a welcome screen that says Modular. And if you squint your eyes a little bit, you'll also see the command to install Mojo. So Modular install Mojo. The CLI itself has a help, and you can see a couple of different options here, which you can use the CLI to update your Mojo installation and also install other things we may have in the future. Okay, but we are interested in Mojo, so what we are going to do is Modular install Mojo, right? You run that. So this goes through the process of installing Mojo. It's really that straightforward. It'll go through this. And if I go back to the screen here, that's the only step we have here. Modular install Mojo, right? That's the only step. And as soon as you're done installing, there's some commands you can copy paste to put stuff in your bash RC file. So Mojo is on path. And then you do Mojo, and voila, you have Mojo installed on your system. And this is the REPL environment. I really like REPL environments because it's easy to interact with it. So shall we write our first Mojo program? And I will do something simple. So print, let's say hello Mojo. Okay. So if you hit return or enter, it doesn't actually print the response because you can do multi-line commands. You can do other things. And if you hit enter twice, then it prints the result. So hello Mojo. Now, if you recall, Pramod said Mojo has Python interop, right? So let's go pull up the blog post here. You see this part? So Mojo has Python interop, which means you can call Python functions via Mojo. And in the REPL environment, you can do that using % Python. And let's do something. What should we do? Okay, import NumPy as NP, because a lot of use cases is going to be in data science and you probably use NumPy. So let me say np.random.rand. Let's do a 5-element vector maybe. And that should print a NumPy array. Now, this is the interrupt in play. So we are actually using Python, using the Mojo REPL, right? So you can call all the vastness of Python libraries that are available through Mojo. But this is not how most of us use a language, not primarily spend time in the REPL environment. So let's quit the REPL environment and let's see how to build and run a Mojo file. So right now, I don't have any Mojo file. So I can say, I can create hello.mojo. Notice I'm using a emoji for a file extension. You can do an emoji or you can do .mojo. Completely up to you. But I like emojis. So here, I'm going to do the same. I'm going to say def main. And do the same thing. Print hello Mojo. Okay. Oh, let's give a emoji here too. Okay, hello Mojo. And then I'm going to save this. So I can run this in a couple of different ways. I can say Mojo hello, and this will execute it and print hello Mojo. I can also build it, right? To create a statically linked binary. So I can say Mojo build hello. And what this does is creates an executable here. You see this? And we can say hello. And now you have a binary that's platform independent and you can share with others as long as they're using the same CPU architecture. So yeah, that's a quick sort of getting started with Mojo. It literally took me, I don't know, maybe a couple of minutes, right? Let me pause here and see if I can answer a couple of questions on the live stream. Okay. Interesting question. I don't know if any of you, Jack, Pramod, River, want to take this. Can Python import Mojo module? The other way, I guess.
Yeah, at the moment you can export functions from Mojo and then import them through Python, but you have to like build the package and export it through that. So yeah, it's a bit of a process to do it at the moment, but we're going to build out tooling over time to make it like a lot more simple.
Awesome. There's another question here which makes me very happy, which is, can you run the Llama Mojo? And for those of you who are not familiar with it, let me go ahead and show you what the question is referring to. So Mojo SDK has been out for a week or less, I think, a week. But the community has really been building amazing packages with it already, right? And this is the one I discovered. I was super excited to see. So if you remember, like llama2.c was a file that Andre Karpathy wrote, which was like a very simple C file that did inference for LLM inference, and a GitHub user actually ported that into Mojo, and this was like a weekend project. It's pretty cool, and he found like big speed ups just out of the box. And I this is him completely working independently by himself, right? It's amazing to see that these projects are coming by the community, and people are sharing and working together to improve it and all that. And we are excited to see what you will port or build with Mojo to get some speed ups with your existing Python code. Okay, so we'll see. Let me see if there are a couple more questions we can answer, and then we'll jump into. So here's a question which is, hey, all developers have access to Playground from Mojo. So let me try to address that. So when we launched Mojo, there was the Playground. If you're not familiar with it, it's a hosted Jupyter notebook environment where you could run Mojo programs, and that was the only way to run Mojo programs until the launch of the SDK last week. So you could log into this Jupyter notebook environment and you could run Mojo code. But with the launch of the SDK now, you can do this locally. That exists too if you want to use it, and this is also an option available to you. Here's a question about, does Mojo work with PyCharm? That's a good question. And at launch, as far as I'm aware, someone correct me if I'm wrong, we only have VS Code support, which we will demo in a moment. But that's a good question, because you can tell us about it, raise an issue on GitHub. Let's track how much interest there is in supporting these. One last question, and we'll continue with the demo. Here's a question I suppose River Pramod could answer. GPU support. Are we planning to support GPUs? I know we don't. I'll clarify that we don't have GPU support today, but is there anything we want to share other than the fact that it would be a nice to have in the future? Pramod?
Oh, I am just going to say that as we showed in the diagram, right, our vision is to support multiple device targets, CPUs and GPUs and other silicon as well. So we don't have GPU support today, as you mentioned, Shashank, but it's on our very short-term roadmap.
Yeah. So I wanted to mention that, because as you download, I want you the user to know that we support CPUs today, and this diagram is our sort of high-level view into the future of Mojo. Okay, so let's pause here, and we'll transition into the more popular way of using Mojo, which is typically through an IDE. Now, Jack will do a deep dive into the extension, but I want to quickly show you a couple of resources that are available for you to get started. So this is Visual Studio Code, your familiar environment. I'm just going to connect to the EC2 instance that I have, where I was running all these examples. So in this instance, I already have my the Visual Studio extension installed. So I'm going to open up the file. You see there's syntax, highlight, formatting, and all that here, and Jack is going to dive deep into that. But what I do want to show you is that we have a GitHub repository with a bunch of code that you can use to get started to learn. There are scripts as well as notebooks. I'm going to head back to our Visual Studio, and I'll say git clone and clone this repository just to show you that there are a bunch of examples. There's also a Docker file if you want to build Mojo in a Docker container, if that's the way you want to interact with Mojo. There are a couple of other scripts here that you can use, including a hello.mojo program just to test it out. There are also scripts and notebooks. Notebooks are here. Let's pull up the hello.mojo notebook. Now, this is a notebook that is a Jupyter notebook, right? You can also run these in the Visual Studio. You can select the kernel that Mojo installs, and you can run notebooks. I personally spend a lot of time on notebooks because I don't do software development. I like to prototype and build algorithms. So I like Jupyter notebook environment. So that is available too. And you can optionally also pull up Jupyter Lab. Let's pull up Jupyter Lab. You can optionally also copy. Hold on. Let's see. Go back to our terminal here. Pull up the more traditional way of interacting with Jupyter servers, and you have the same environment. If you want to run stuff in this mode, then this is also available for you, right? Okay. I'll pause here and let's see if we want to answer a couple of questions, and Jack will take over and dive deep into all things Visual Studio extension, because that's exciting for a lot of you, I know. All right, let's see. Can you show us a demo of Mojo extension on Visual Code? Thank you. We will transition into that right now. And Jack is the expert on that, so we'll dive deep into that. All right. Any other questions that you want to answer? Support for frameworks and okay. This I think Pramod. There's a question about license for the SDK. Can I read the license anywhere? Do you know where we can point people to?
Yeah. So the licenses are there on the website. So if you go to www.modular.com/legal/Mojo, our Mojo license for the SDK is there. You guys can review the license.
Is it the right place?
Yeah.
Oh, okay. All right. So there it is, folks. All right. Okay, so another question, is there any Docker image for Mojo? On the GitHub repository, if you head over to examples, under examples, we actually have a directory called Docker. There is a Docker file. You can use this, repurpose it for your use case. Unlike you, I personally like to do stuff in a Docker container because of the isolation and doesn't mess with my system. I don't like to install stuff in my system. I like to work in Docker containers, but different people have different preferences. Docker, native install, all of that. So there is a Docker file for folks who want to use Mojo and Docker file. What you'll need to do is actually add your modular auth key. Here you need to update this. When you'll get that access to that when you log into your developer console, and update it and build your Docker container, and you should be good to go. I like doing that too. All right. Okay, we'll pause here. Let's transition to the Visual Studio extension demo, and we'll continue to answer questions moving forward. All right. I'm going to share Jack's screen now. Jack,
Cool.
what do you have for us?
Thank you very much. So I'm just going to be going through the extension. So when you first type in Mojo into extensions, you can bring it up here, and then it shows you all the different things that you can do with it. So we're going to be updating this over time as we add features. So please come back here and see all the things that we're adding. So the first thing I'm going to be doing for this demo just going to be going from and then pressing Control Space, and then that brings up everything in the standard library. So we're looking in algorithm, and then if you don't see these little hints at the right here, you can press Control Space to bring them up. So we're going to get functional and then import, and I want to get vectorized. So we'll go over what that does in a second. We'll create a main function, and then for I'm going to purposely do something wrong here to show you that you can bring up these errors up on the same line. So if you haven't seen this before, this is a really cool extension called Error Lens. So if you go into the extensions, it's really cool because it shows you exactly what you're doing wrong, and you get fast feedback as you're going. You can fix it as you go. So we'll go for I in range, fix up that, gets rid of it, and then we can just print it out. Now run this in my terminal, and you can see it's doing a loop, so 9 different items. And the way I'm running this really fast is I've set up a keybind. So if you go into keyboard shortcuts and you type in Mojo, you can bring up all the things that you can bind keys to. So I just put it to Alt-M. And then what we want to do now is have a look at vectorize. So if we bring up the doc hint for this, it'll show you the signature. So I'll go over this in a practical way, so I won't talk about the description. But the first thing we want to do is pass in this SIMD width. So in Mojo, anything between square brackets is a parameter, so that means it's compile time known. And anything between normal braces is an argument, so it can be compile time known or it can be a runtime known value. So we'll put in 4 to start, and then we also need to pass in a function or a closure. So I'll call this closure, and then to start with, we'll just print an empty line and pass it in. And now the extension is telling us that we're doing something wrong here, so it expected func with a parameter of int and an argument of type int. So we'll put that in there now. We'll call it else int, and then I int. And let's have a look at what it is. So putting else elements at, and then I. So if we run this now, we'll do 9 as well and run it. And you can see instead of doing 9 instructions, now it's doing 3 loops. So 4 elements for the first loop, 4 for the second, and then the leftover is 1. So there's 1 left over after those 2. Something else I'm going to do as well, because we're going to keep reusing that 9, I'll just do an alias. So alias size type int equals 9. Size, and then put the same thing in there. So you might be wondering, what is the purpose of this? Like, why would we want to do this if you haven't done anything with vectorize before? So to show you that, I'm going to bring in another thing called from memory.unsafe import dtype pointer. Sorry, I missed a thing there. Dtype pointer. So let p equal dtype pointer, and then we'll give it a type. So you can see here, this is like NumPy. You have all the different standards here, so you can see what types we're using. And we want to just get the int16 and then allocate that to the heap. So we'll put in the size. So we're allocating 9 elements of size 16 to the heap. And then we can use that inside here. So we'll store the elements. SIMD store. And yeah, as you're going through, you can look at these hints to show exactly what it's doing. So it needs a width, offset, and a value. So the width goes in as a parameter. So we'll go SIMD store and then put in else. So that's coming in from here, and you can see we're going to put 4 elements at that position. So we'll go I, and then we'll put the same I, like, so we're putting it at position 0, and then we'll put the value as 0 as well, so you can see what it looks like. Now we're getting this error up here. This is telling us that we can't capture things inside here unless it's a parameter function. So I'll just get rid of this loop. You can see this P here, we're using this inside the closure. So now that we're doing this, we need to mark this with a decorator, saying parameter. So now we can pass this function in as a parameter. And if you want to get more details about what all this means, highly recommend checking out the programming manual. It goes into a lot of details about all that kind of stuff. We'll just make sure it's working, which it is. And now we want to have a look at what it looks like. So we'll go p.simd load, and then we'll get everything. So we'll pass in size and position 0. Now this is telling us that the value is unused, so we want to print it out. So we'll go like this. Print it. And now you can see the vector at the end here. So the first 4 elements are all 0. The second 4 are 4, and then the last leftover one is 8. So instead of doing 9 loops with all those CPU instructions, we're just doing 3 loops. So it's a lot less instructions for the CPU. So this is what people mean when they talk about vectorize. They're speeding up the algorithm. But at the moment, this is not really optimized for any kind of hardware. So there's something else we can do here to make things so we can experiment a little bit more. I'll put another alias in and just change this. So I've just made an alias with the type so that we can change that. And then the other thing we want is to figure out how many of these int16s we can fit inside our SIMD register. So for that, we can go into sys.info and then import. And if you type in SIMD, it'll bring up all the different things to do with SIMD. And we want SIMD width of. Now we can go alias and else equals SIMD width of. And we want to pass in the type. And I'll just print that out so you can see what it is. So you can see we can fit 8 of these int16s into our SIMD register on this computer that I'm on now. So I'm going to chuck that in here now. And so instead of 4 and 3 different loops, we're just doing 2 loops. The first one is 8 zeros, and then the leftover 1 at the end. Cool, so we can increase that a little bit. We'll go to 64. And you can see we're doing like 8 loops now. And you can see the SIMD vector at the end here. And then if we decrease the size of this type, so we go int 8, then it's a lot less instructions. So the smaller the data type, the more efficient your algorithm is going to be. So hopefully this teaches you a little bit about what vectorization is and also shows you how to use the extension. There's some other cool things you can do, like if you want to put in your own doc hints, you can, and it's just normal markdown. So you can go, this is a comment. And then you can do like little code blocks as well. So let I equal 10, print 10. And then when you have a look inside here, then you'll see the markdown. So it's a nice markdown experience.
That's cool.
Yeah, and just one last thing. So the last thing I'll do is these quick fixes. So if you have a look here, when you hover over things that the LSP knows how to fix, you get these little light symbols. So you can press it and then put it in and it will fix it up for you. So we'll add more of those over time. So yeah, keep checking back and we'll keep adding helpful things in there. And yeah, that's it. Back to you, Shashank.
I know you were you wanted to show the visual power of Visual Studio extension, but you actually showed some very cool features in Mojo itself, right? Like being able to use SIMD and like vectorize code. That's it's not easy, folks, to do it do in other languages. That's pretty cool.
Yeah, definitely. Like if you have a look at C++, doing like a similar thing is very difficult. You got to learn a lot about like all the intrinsics and stuff like that. So Mojo makes it really nice and ergonomic.
That's awesome. And you were using a couple of keyboard shortcuts, I think, Jack, to run right, to run the script that you had. But there's also a cool button on the top right.
Yeah, I'll show you that. So you just press this little play button, and it will do the same thing. If you don't like keyboard shortcuts, then you can just press this. Yeah,
and the extension page on the marketplace has some pretty cool guide that you wrote for keyboard shortcuts and all that, right?
Yeah, we'll keep updating that as we add features. So keep checking back on there.
Awesome. Yeah, I think this highlights the point that the usability is equally important, right? A powerful language is good, but having a good IDE support and extension will help you be more productive, especially while learning a language with syntax that you may or may not be familiar with, right? Mojo is a new programming language. That's awesome. Again, like feel free to drop in questions and we'll try to answer. Here's a good question. I think you should address this, Jack. Someone's asking, and I had the same question too. The difference between the square bracket and the parenthesis thing, right? It's new to Mojo for a Python user, right? You want to quickly take that?
Yeah, so in Python, argument and parameter can be used kind of interchangeably. They have like a slight difference, but in Mojo, it's very specific. So a parameter means that it's compile time known value or a type. And then an argument in the normal braces means that it's an argument. So it's just a value that can be known at runtime or compile time.
Right. So yeah, the square brackets where Jack added all the type information, so compile time information. Awesome. I thought so. There's a question here that I think we should on platform support. So someone asked they tried to install it on Debian 12 and they couldn't install it. Is that, I know we support Ubuntu, like I use it on Ubuntu. Is that something we support today, Debian?
No, it's not currently supported, but some people have figured out workarounds to get it working. But yeah, we'll get to that eventually. But currently only Ubuntu supported, with more support coming for all the other operating systems soon. You can get it running through the Docker container that you showed. That's the easiest way to do it right now.
Right. So that should still work if you're on Debian, if you do the Ubuntu container, right? That should work?
Yeah, that works, yeah.
Okay. Awesome. And someone else asked a question a couple of times about Windows support. I think we should clarify that, right? So you can do this on Windows today using WSL, Windows Subsystem for Linux, right? It's pretty straightforward for you to install, and the install instructions are on the page that we shared earlier, which is here, drop down Windows, right? Native Windows support is coming soon, as you see on the website. So stay tuned, but shouldn't stop you from trying Mojo. You can try Mojo today if you're on Windows too. All right. Okay, someone's asking this. I don't know who wants to take this. I think it's an interesting question for anyone coming from Python, right? Why do we need def and fn functions? I can take a stab at it, and someone else can add more color there, right? So Python, you're used to def functions. Mojo also has fn functions. From the documentation, you'll see there's a section on key differences. I should probably pull it up here. Also highlight the fact that we have an awesome documentation. So in the programming manual, actually, you'll see there's a section here on fn and def. I need to go find exactly where it is. So fn functions are more strict. So you have to add types, type annotations. It's mandatory. It's required. Def is a little more gives you freedom. Like you can add if you want to. Like return types are not necessary. Argument types are not necessary. Whereas in fn it's strict. What that does is give more information to the Mojo compiler, so it can find more optimizations to speed it up versus def. So that's sort of the benefit of using fn over def. But for folks coming in from Python, right? I mean, you're familiar with Python syntax, so you can use def and continue to add all those type annotations and still get the same benefits of fn. So it's just you have an option to do that. If anyone wants to add more color to that, please do. Okay.
Yeah, just say like the other. Sorry, River, do you want to go?
I mean, Jack, if you want to take it, go ahead.
The only thing I was going to add was for the errors. Like, so if you're in a def, then you can interact with Python, and you don't have to handle the errors. Whereas if you're in a function, then you have to handle all the errors. So if you're using a def or using Python interop, then you have to make sure that you check for errors and then print the error if you need to, or handle it however you need to.
Awesome. All of this stuff is in the doc. We have a nice doc and a programming manual too. So a lot of those basic questions that I had myself too, right? Coming in from Python. Why are things the way they are? And there are plenty of examples in these. And of course, like, it's a new programming language. We're improving this every day. So if there is something missing, something not clear, please go file an issue. We want to see more of those because that's how we improve the language, improve the documentation, improve the samples. All right. So let's see. Someone's, I think it's not a question, but a comment. Loop unrolling does not get any easier than that. It's unprecedented in a Python dialect. someone is saying. So I think a lot of the features that Jack showed with SIMD and vectorization and loop unrolling, I mean, it was new to me too, right? Coming in from Python, I think that's pretty cool. It's one of the reasons why you can get a lot of speed up, taking advantage of those vector units in your CPU. I think Jack showed 16-bit. You get 16 times 8. That's like 128-bit registers, I think, on the computer you were using, right? So
Yeah, I'm on a MacBook at the moment, so
okay.
it's 128. But usually, if you're on an Intel CPU, they're
Right.
512 usually now.
Right. Yeah. If you've seen things like AVX 512, that's what it means. There are these. You can use SIMD to actually parallelize your operations there. On Mojo, so that's pretty cool. But you're right. Some of these capabilities are what makes Mojo faster. And someone's talking about. I don't know, someone, Jack or River Pramod, if you're familiar with the VS Code setup process, can you talk about the modular home path value in VS Code extension? I was having issues using it with WSL2 on VS Code. Is that set automatically, or does a user have to explicitly set that? Do you know?
Yeah, if you forget to set it when you're doing the install process, so that step that you showed, filling out your bash file, if you don't set modular home there, then you can set it manually in VS Code. In WSL, you just have to make sure like the path might come out wrong. So you have like a little $sign WSL. You need to get rid of all that and then just put your home path. So like /home, then your username, and then .modular. And that's all you need in there.
Awesome. Yeah, I don't not a Windows user, but if you follow the instructions on the output of the installation, when you do Mojo module install Mojo, there's some instructions. If you do those, the right path should appear in the.
It's kind of tricky. So the extension tries to pull it from your environment. So if you set it from after the install, VS Code might be smart enough, depending on how the VS Code server is initialized, to pick it up. Otherwise, you can set the modular home path explicitly in the extension to whatever comes out of your installation output, as kind of like a fallback of, you can't pick it up from the environment, just set it directly, kind of thing.
So, River, the question about platform support, I think briefly Pramod mentioned. Do you want to share more on platforms we support today, or we will or plan to support? Because people are asking questions about Windows and Mac and Linux and Debian and all that. I don't know, is there any broader way to address this?
I can answer that one. So I mean, if you scroll through the chat, there's so many questions on different platforms, whether that's different flavors of Linux, Mac,
Right.
or Windows as well. So I mean, right now for the public distribution of the SDK, we only support Ubuntu 20 and 22, I think. But if we go to the blog post, you could see that technically there's like Mac and Windows and also GPUs as well listed there. And I think that's just about us rolling out support. So internally, for example, I develop a lot on Windows, and I care a lot about developing on Windows. We have users that develop on Mac. So we want to make sure, and we do make sure, that the experience is really awesome. I think for us, it's really just about planning out when we want to roll those out to the community and making sure that when we do roll it out, that the experience is very good. So we can't promise timelines because timelines are always tricky, but do know that getting this out to as many people as possible so that they can experience the same thing we do internally is very important, especially over the coming months.
Awesome. Here's another question from on the stream, which is I'll read it as it is. Is the def in Mojo and the def in % Python blocks different? Is def in Mojo a UI convenience? I'll take a stab at it.
I'm happy to answer it.
Oh, yeah, go ahead. Yeah, go ahead.
So % Python in the REPL or Jupyter is basically a convenient way to directly run Python code. So it's run in Python directly. So whatever you type there can be whatever valid Python that you want. Def in Mojo is different. It's kind of a different flavor on dynamism. So you still support the Python syntax, kind of the dynamic behavior that you would expect from Python, but it's not directly Python. So there's a difference in what they mean. So %% Python is really Python, whereas def and Mojo is our own take and evolution of the concept of dynamism.
And I learned this through trial and error too, which is this behavior is in the REPL and the Jupyter notebooks, right? Not if you're building writing a Mojo script. So if you're in a Jupyter notebook, one of the cells could be % Python function, the other cell could be pure Mojo code, and you can actually call the Python function from here as long as you take care of sort of the that stuff that you're passing and resolve it, the Python object and all that. But if you're printing stuff, you can pass. So that gives you like this nice interop. But if you're writing a Mojo script, you have to import it as a Python package. Is that right, Mojo? Is that right, River?
Yeah,
Cool.
yeah, exactly. So one thing that we really want to prioritize with the REPL or Jupyter is that kind of like connection and swapping between the two. Whereas if you're developing just like a Mojo file directly, you need to use the Python interop API as part of the standard library. So all %% Python does actually is just use that same API from the standard library, but in a more convenient fashion. So if you're in Jupyter Notebooks, you can significantly more easily interop between Python, especially if you have notebooks or testing or setup phases that you have in Python that aren't as easy to do in Mojo at this point.
Awesome. What else? A couple of other questions here. I think Pramod briefly addressed the question about debugger. Just to clarify, it's not. Is it there in the Mojo SDK that we download today, or is it a coming soon thing?
Yeah. So people might see some things, especially in the extension. There's an quote unquote experimental way to run or debug a Mojo file directly. The Mojo driver also has some, I think, experimental debug level options. So in the SDK that's shipped publicly, the debugger is not really on. It's more of an experimental thing that we're still like getting to a level of quality internally before we expose all of the features and functionality. So right now, the debugging experience for the public SDK is not going to work as you would expect. But that's something that is really important to us internally, especially. So that's a huge focus. But you might see things like LODB shipped with the SDK, but that's mostly also because all of the REPL and Jupyter environment is actually built on top of LODB as a debugger. So that when we have debugging features, the stuff you do in the REPL or Jupyter is actually debuggable with LODB at the same time. So there's a lot of interop and connection between the tools that we develop, making sure that as we build things that the experience is just going to be significantly better than what you might expect from other places. But it's not available yet there.
Great. Another question, and I don't know how to interpret this. I'll ask it. Maybe it makes sense to some of your Rust users there. Is there a guarantee like Rust if your program compiles? Is it most likely is good for production? I'm not a Rust user, so I don't know how to interpret it. But does it make sense? The question?
A bit. One thing that you really want to keep in mind is that Mojo's still early in development in terms of like use for production, for like wide general production use cases. Mojo aspires to have a lot of the things from Rust and other languages in terms of memory safety and making sure that you can actually know that your program is safe. But a lot of that stuff is still being built and is still in flux. So I think that's an aspirational goal that we have. But in terms of what you have right now with the public SDK, like just remember how early everyone is actually in this process for all of this.
You're all helping us improve the language every day as you use it, actually. But the best way to let us know is, tell us about what worked and what didn't work. There are a couple of questions here that we addressed in the previous live stream. There are a couple of questions about Mojo and open source and all that. So I encourage you to check out our previous live stream. We had Chris Latner there, Abdul Jeff Pramod. There's a good discussion. A lot of questions were answered. So the recording is in YouTube. Feel free to head over there and watch the previous live stream. We also have like a short 5-minute version of that live stream with popular question and answers. So I highly encourage you to go check that recording for answers to some of those the questions about the language and the decisions we made about the language and so on and so forth. There's another question here. I think that's talks to the Python interop, which is HTTP methods for standard library, right? Do we support it and stuff like that? But I think I saw some community examples about people using Python interop to show that. I don't know if any of you have seen that. I thought it was pretty cool. I guess the takeaway there is like, if something is not there, you can always use the Python interop to do that today. It shouldn't stop you from building applications, right? Although I can't comment about what will be showing up in the standard library in the future because I don't know.
Yeah, there's a lot of interest for fast API. A lot of people like that
Right.
library.
Yeah.
It's a little bit difficult at the moment to be calling Mojo functions from Python. So there's a bit of a process doing that. But yeah, over time we'll build out tooling to make it really seamless and nice. So stay tuned for updates on that.
Awesome. Do we couple of questions in the broader theme of IDEs, right? So we have the Visual Studio extension. I saw a couple of questions asking about Vim and Emacs and PyCharm support, I suppose. Do we want to share anything else there, River, other than let us know what you're using and file a GitHub issue? Do you want to share anything more there at this moment?
Yeah, I can talk about a little bit of what my philosophy is with when we're building this stuff, which for me, the major focus, especially because Mojo is so early, is on building out like significantly powerful LSP as a general technology. So right now, a huge focus is on the VS Code environment, but that's just because it's one thing that we can focus on for making sure the LSP is really good, interactive, things like that. But I know people have answered in the chat as well. We have people internally that use Vim, Emacs. There's different IDEs that already have connection points for LSP, and they already kind of benefit from the technologies, just kind of like connecting it to the server. None of that stuff is shown publicly yet. We're still figuring out ways that we can have like official distributions for connecting to some of these other IDEs. So that's kind of the way that I approach it moving forward, is build general technology that can hook into different places that support that. So any IDEs that support LSP are useful for us, especially because then we can just focus on one technology. But outside of that, it's really based on interest, like where the community is, where people use different IDEs, and kind of meeting people where we are. But that goes back to the philosophy of Mojo as well, with being a superset of Python.
Awesome. Here's another question that I think is a pretty common question. Should I expect performance boost by simply importing Python code as is into Mojo without any changes? Who wants to take that?
Yeah, so at the moment, no. Anything that you import through the C Python interpreter will run the exact same way as it does currently with Python. Over time, we may build out features to be able to speed up like Python is imported. But currently, at the moment, no, it just runs through the C Python interpreter. So if you want to get the performance improvements, you have to rewrite stuff in Mojo or bring it into a def function. And you might have to change some things because we haven't implemented all the Python features yet. But you'll get performance improvements the same like 10x just by bringing it into Mojo without making any changes.
Right. When we talk about bringing Python to Mojo, I think there are really two separate things. One is the interop way to bring things in. The other is re-implementing, like we've shown in a couple of our blog posts, wherein what small changes can you make to your function so that it becomes a Mojo function, right? Adding those types and those return types and all that. I think both can be quote unquote bringing Python to Mojo. So the interop would use the Python's existing engine, and those slight code changes you can do depending on if you have classes and stuff which we don't support today, then you can't bring it in. But if you have simple functions and you bring it in, like we've shown with our Mandelbrot example and the matmul example and a couple of other examples, the Euclidean distance example. So there you will see huge speed ups just by adding those small things. So yeah, I guess that's the summary of like how are you bringing it in and what minimal effort you need to do to see speed up. And again, it's a new language, it's growing, and it'll only get better every day. Okay, I think we've covered most of the questions that's here. And again, feel free to add questions in. We have 5 minutes left, but we can continue to answer questions if you have. Okay, here's one. Okay, I think this is an interesting one. We've tried to address this in the past. Can Mojo code with Python interop be statically linked? Who wants to take that?
At the moment, like I was planning on experimenting with this because there are some Python packages like something called Jupyter where you can package stuff statically and ship it in a single binary. I haven't experimented with it yet, but yeah, there's existing tooling. So if you want to try that out, then it'd be awesome to see your results in the Discord. So yeah, if you do get it working, post it up in GitHub discussions or Discord. That would be great.
So the to answer the question that was not asked, if you do that and build, you get it's dynamically linked, right? So you have to
yeah, the place where you're running it from.
Expect the same version of Python in the wherever you deploy to. Is that right?
Yeah, that's right. It links to your local environment, so you have to have those same Python packages installed wherever you're running it from.
Awesome. Yeah, I think that's a big one, right? Like a lot of new users would be using Python interop a lot to fill some of those use cases. All right.
I think that question is also kind of similar to other questions that were asked earlier about what it actually means to build something from Mojo, and I think that can be easily clarified that we generate native binaries. Like when you do Mojo build, it's a binary as you would build from C++ or anything else. There's no like full runtime built on top of it. Like there is a legitimate main function that is run. So everything is native. So like Linux is ELF, Windows is the exe files, that type of stuff.
Awesome. I was scrolling back to see if there's other questions that we missed. I noticed a few other questions about ID support, but there's one about contributions. Looking at the GitHub repository, are contributions limited to those with access to Playground? Should we submit issues rather than attempt to solve them? Can you explain how Mojo open source culture and how we want to, I guess, accept feedback?
Yeah, I mean, Mojo is, I mean, it's not, I mean, just users on the Playground, they're not restricted. I mean, there's no restriction for filing issues or, discussions. Like we encourage that. You don't have to have a Playground account. Now,
anybody can, right?
Yeah, anybody can. Anybody can just file an issue. So if you're running into, issues with using the SDK, then please file an issue. We're constantly monitoring the GitHub. We can help you, or you can come to Discord. There's a very active Q&A threads also available on Discord to help you. So it's not restricted in any way.
Awesome. Yeah, so file an issue, but if you see something that you want implemented or something that's broken, but at the moment we are not accepting pull requests, are we, Pramod? Is that something we
pull requests on Mojo? No, I mean not at the moment. But yeah, we are working on a way to figure out contributions even for the examples. So if you have if you wanted to add some examples, we're also working on a way for you guys to contribute examples to us. So yeah, please stay tuned. We're just trying to iron out some final things internally.
Awesome. I think we went through all the questions, and again, a couple of questions about Max support, and I can only say stay tuned, right? Awesome. So I think we've answered all the questions. We are also at time. We have 40 seconds left, I suppose. So let's wrap up here, and we'll do many more of these. So please come back and ask us more questions. So any last things to add before we wrap up? Pramod, Jack, River?
Yeah, there was just one question about if we're hiring, and we definitely are at the moment. So check out the website and the careers page, and we'd love to see your application. So yeah, thanks for asking that question.
Awesome. Yeah, so we'll wrap up there, and just to sort of quickly summarize, Mojo SDK is now available. Please go and download it, try it yourself, give us file issues, let us know how you like it. And we'll do many more of these. The recording of this live stream will be available on YouTube. Also, the previous live stream is available on YouTube. And we'll continue to do more of these. We'll try to figure out what type of content works best for you. Code walkthroughs, example walkthroughs, or Q&As with folks building Mojo and making decisions for Mojo. So those are different topics we'll cover in the future live stream. So be subscribed and let us know what you want to hear too, right, in the live stream. Or the other thing is join our Discord. We have an awesome community of Mojo users there. A lot of the questions that you're asking, others are asking there too, and most of us working on Mojo are in the community answering those questions too. You may find some familiar names here in this live stream. With that, we will close. So thank you for joining us, and we hope to see you in the next live stream. Until then, happy Mojoing. All right. Thank you.
Cheers. Bye, everyone.